Okay, sinusoidal graphs, here's the homework. So sketch one cycle of each of the graph for each equation. Okay, so I have y equals 3 sine x. So when I'm looking at this, I know that this is a vertical stretch by 3. That means our amplitude is 3. So let's go 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6. So none of these have a horizontal stretch or compression. So we're going to graph all of these as 90, 180, 270, 360. Okay? So when dealing with sine starts at the origin. Okay, I'm going to do this one in green. Sine starts at the origin. And because now we have an amplitude of 3, we go up to 3. Then we go down 3. And we go down 3. Then we go up 3. Okay? So the maximum is going to be 3, the minimum is going to be -3. Okay? Y equals 5 cos x. So we know that the amplitude now is 5. Cos starts at a maximum, and then it ends at a maximum. So that's going to be 5, and we're going to go all the way down to -5. So we're going to go down to the equation of axis, and we're going to go down again, 5 and 5. Then we're going to go up 5, and then up 5. Okay? Y equals 1.5 sine x. Well, we know the amplitude for this one is 1.5. So sine starts on the equation of axis and starts by increasing. So we're going to go up first to 1.5 and down to down by 1.5, down by 1.5, and then up by 1.5. Okay. And it's supposed to be yellowish. There we go. Okay. Cos 2/3. So cos starts at a max, goes down, down to a min, and then up, up to a max. So let's start at 2/3. We're going to go down to the equation of axis and down 2/3 again, up to the equation of axis and up to 2/3 again. Okay, so number 2, sketch one cycle for each of the graph for each equation. Okay, so when I take a look at this, I know that there's a horizontal stretch or compression. What that means to me is that the period, it's either getting longer or shorter. Okay, so this is a horizontal compression. What we need to do is we need to say, okay, so usually our period is 360, but this time it's only 180. Okay, so we're going to do a full cycle in 180 degrees. Okay, sine 6x, I'm going to do all of these kind of at once just so that we can label the x-axis appropriately. So this is getting divided like it's 1/6 as long. So this is going to be 60 degrees. And then 360 divided by 3/4, which is just like 0.75 if you think about it. This is 480, so this is lengthened. This is a horizontal stretch, okay? So let's go from 0 all the way to 480. So 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to do 60s. So 60, 180. 60, oh, that's 120. 40, 300, 360, 420, and then 480. Okay, so for the first one, we're going to graph an entire rotation from 0 to 180. So 0, we know that sine lies 3 times on the x-axis. So 0 and 180, the front and the back, then halfway through. But halfway through would be the 90. Okay, So halfway between 0 and 90, which is 45, our sine's going to go up and then down. And then 45 more, which is 135, our sine graph is going to go down and then up. So one full rotation on 180 degrees. Okay, now I'm going to make one full rotation by 60 degrees. So sine, 3 times sine is on the equation of axis. So at the front, at the back, and at the middle. So this middle number is going to be 30 this time. So half of 30 is 15. So we're going to go all the way up by 15 and all the way down. And then all the way down and all the way up. Okay, and then that would be 45. So again, one full rotation by 60 degrees. Now we're going to do a full rotation on 480 degrees. So the start is 0, 0. The end is 480. Halfway through would be 240. Okay, so halfway between 0 and 240, which is 120, we're going to have to plot a maximum. You can come back down. And halfway between 240 and 480, which is 360, we're going to have to plot a minimum and then come back up. Okay, and now we're going to do D, E, and F, which involve cos. Okay, so with the 3, we know that's a horizontal compression by a factor of 3. So instead of rotating in 360 degrees, we're going to rotate in 120 degrees. Okay, 1/3. We have 360 divided by 1/3. This is actually like multiplying by 3. So that whole rotation is going to happen in 1080. Okay, and then 360 divided by 1/4. That's like multiplying 360 by 4, which is 1440. Okay, so we can clearly see that this is a horizontal stretch and this is a horizontal stretch as well. So I'm going to go with my biggest one to choose my scale, okay, just because I'm going to put these all on one graph. 1440, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9. It gives me 160. So you know what? I'm going to use 180. I always use numbers that are multiples of like 30, 45, or 60. Okay, so instead of doing 160, I'm going to do 180. So this is going to be 180, 360, 540, 720, 900, 1080, so that works, 1260, 1440. Okay, and then 1, 2, 3, we'll just go up 3 for 1 unit. Okay, so this one's a little bit different because we're dealing with cos. So we're going to do one full rotation of cos by 120 degrees. So cos starts at a maximum and then ends at a maximum. Let's say 120 is here. Okay, between the two of these, we're at 60, and 60 is going to be a minimum. And then between 0 and 60 is 30. So we're going to go down 30 degrees, down 30 degrees, up 30, and then up 30. Okay, E might be a little bit more clear. So cos, again, starts at a maximum. So we're going to be at a maximum at 0 and 1080. Halfway between these is 540. So at 540, we're going to be at a minimum. So what's halfway between 0 and 540? I'd say 2 something. 270. Okay, and then 270 past the 540 would be here. And that's cos 1/3 x. Okay, if our period is now 1440, we plot at a maximum at 0 and a maximum at 1440, and we go in the middle of these two, which is 720. 720, there's going to be a minimum. Okay, so then that means at 360 degrees, we're on the equation of axis, and then also again at 1080, which is like 360 degrees past 720. Okay, number 3, write the equation of the sine curve with the following amplitude and period, and then sketch one cycle of the graph. Okay, so the amplitude is 6, so we would have y equals 6 sine, okay, because the amplitude's always the a value. Now the period's 180, so in order to get the k value, we would have to divide 360 by 180. So in the equation, we're going to have a 2, right? And if you think about that logically, 180 is half, right? It was a horizontal compression by a factor of 2, or like 1/2 we'd multiply it by, so we'd put a 2 in there. So now, amplitude is 6. 1, 2, 3, 4, 5, 6. And -6. We have two periods here, 180 and 240. So I think going up by 45 is going to be okay. 45, 90, 135, 180. And it's 270. Yep. Okay. So let's do this one. We're going to do this in green. Okay. Sine starts on the equation of axis. It ends on the equation of axis. And the middle point's on the equation of axis. Okay. So we go up to 6, and we go back down, and we go down to -6, and then we go back up. Okay, the equation for the second one here, y equals 1.5 sine. Now, a period of 240, our actual value in the equation would be like our 360 divided by 240. And it's 3 over 2. So we get 3 over 2x. So our graph is going to start at 0, end at 240, say it's here. Okay, and then what's half of 240? 120. So 0, 120, and 240. We already know points. Now, between 0 and 120, we have 60. So we're going to go up to 1.5, down to down by 1.5. Okay, down by 1.5, up by 1.5. And that's our second graph. Okay, number 4, write the equation for the cosine curve with the following amplitude and period. Okay, so nothing changes in regards to the amplitude or period and how that's represented in the equation. So it'd be like y equals 3 cos. Okay, this number is always going to be your amplitude. Okay, now if the period's 180, then it was a horizontal compression, right, by 2. So we have 2x, because 360 was divided by 2 to get 180. Okay, so we need to get from 0 to 180. In this second one, we need to get from 0 to 720. Okay, so just so that we make the scale appropriate again, I'm going to go up by 90s. Okay, so I get 90, 180, 270, 36, 450, 540, 630, 720. Okay, so for the first one, this is a cosine curve. We're going to start at a maximum. Our maximum is going to occur at 3. So maximum, we're also going to end 180 degrees later at a maximum. Now halfway through, which is at 90, is going to be a minimum. Okay, and halfway between those 2 points, equation of axis and equation of axis. Okay. So 1 full rotation of cosine within 180 degrees, and we stretch the amplitude to 3. Now, the amplitude is going to be 1/2 this time, which is here, and this negative 1/2. Okay, so we're going to start at a maximum. So at 1/2, 720 degrees later, there's going to also be another maximum. So halfway through, there's going to be a minimum. Oops, it's not -3 anymore, it's -1/2. Halfway between 0 and 360, which is obviously 180. Right? There's going to be an equation of axis point, and then another equation of axis point. Okay, so I'm going to put these three on the same graph, and they include both horizontal and vertical stretches and compressions. Okay, so for the first one, we're going to go up to 2. So the amplitude is 2, which is going to be the max. Okay, the min is going to be then -2. Okay, and we have a 1/2 x. So if we took that 360 and we divided by 1/2, the period is going to be 720. Okay, so let's go 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6. Okay, but for B, let's figure out the amplitude. So the amplitude is 5, and if we had 360 divided by 2, we would have the period of 180. So the 180 will still fit if we took 720 and did our x-axis. This is the one I wasn't sure about. So 360 divided by 4/5. 360 divided by 4 divided by 5. It's like 360 divided by 0.8, which is 450. Okay, and the amplitude here is 2.5. So let's go back to the first one. 720 is our biggest, our longest period. So we're going to divide that by 980. We're going to label by 90s. So 90, 180, 270, 360, 450, 540, 630, 720. Okay, let's go ahead and graph the first one here. Let's go purple. Okay, we're going to do sine, and we're going to start on the equation of axis, end on the equation of axis, and halfway through, we're going to plot a point on the equation of axis. Now, we're going to go up by 2 halfway. Okay, so 0, 180, 360, and we're going to go down by 2 halfway. So max 2, min -2. Okay, B is going to change a little bit because we have a reflection in here. So nothing's going to change with the equation of axis, right? Because even if we reflect 0, that's not going to change. So we know 1 full rotation is in 180. So let's plot the start point at 0, the end point at 180, and the middle point at 90. All of those lie on the equation of axis. Here's what changes. Okay, so our amplitude's 5, so we're going to go up to 5 and down to -5, but we're reflected. So instead of the sine curve going up first, what we're going to do is we're going to go down first. Okay, so we're going to go down, and then up, and then up, and then down. So this should look curvier. Okay, so this is our new sine curve. Okay, and now this one. Okay, again, oh, this one's cos. Okay, so with the cos curve, we're going to be at a maximum at the beginning, and then add a maximum at the end. Okay, here's the difference. There's a reflection. So instead of starting at a maximum, ending at a maximum, we're actually going to start at a minimum and end at a minimum. So I'm going to plot our minimum at 2.5 or negative 2.5. And 450 degrees later, because that's the period, right? Period. I'm going to plot another minimum. Halfway between those, I'm going to plot a maximum. So at 2.5. And then I'm going to have between these 2 points right on the equation of axis. All right, number 6, write the equation for the following sine or cosine curve. Okay, so I'm going to assume that there's like no transformations for these ones, just looking at them. So this one starts on the equation of axis, so I'm going to call this sine. Okay, so we're going to go y equals something sine. Now, amplitude goes here. So we go up to 4 and we go down to negative 4, so the amplitude is 4. Okay, and the period, one full rotation, is 360, so that's just 4 sine x. Okay, it doesn't affect this k value here. Okay, for b, here's the thing, it starts at a maximum, so I'm going to call this cos. So we're going to have y equals something cos. Okay, the amplitude, so we go from negative 3 to 3, so the amplitude is 3. Now, one period is 1440. So what did we have to divide 360 by to get 1440? So in other words, I'm going to go 1440 divided by 360 is 4. So we would have had to divide 360 by a quarter, right? So if we had a quarter here, what this would mean is a horizontal stretch. So we'd be multiplying it by 4. Okay, C. We're actually starting at a minimum this time. So instead of talking about any phase shift here, which we didn't really focus on in this set of homework, what I'm going to do is I'm going to take into account that there would be a reflection. Okay, so minus something, but because we're at a minimum, I'm going to call this the cos function. Okay, we're going from negative 2 to 2, so that's our amplitude. And one full rotation is 720. So that's just double 360. So I'm going to put a half in there because we know that we had a horizontal stretch by a factor of 2. Okay, last one. So we started at a maximum, so I'm going to call this the cos function. Okay, amplitude would go up 1, down to negative 1, so that would just be 1, but you don't really have to write that in. Okay, up to you. Now, a little bit awkward. One full rotation takes 600 degrees. Okay, so I would do the 360 divided by the 600. And I get 0.6. Okay, and we know 0.6 is 3/5. Okay, so if we were to put 3/5 in the equation, we know that this was a horizontal stretch by 5/3, right? The reciprocal of that. So here are the 4 equations.